And we are going to create equations from the matrices. So we have first equation right here. 3 to the 2x minus 2 minus x equals 7 plus x. So when you have a binomial in a particular place in the matrix, you want to make sure you put parentheses around it if you're subtracting it so that you can distribute the minus sign. Okay. If you subtract x from both sides, these x's go away. And you get 3 to the 2x minus 2 equals 7. And then you can add the 2. And you get an exponential equation. You want to rewrite 9 so that it has a base of 3. If you can't rewrite 9 so that it has a base of 3, you use a logarithm with that base. So there's two ways to solve this. So you can either rewrite 9 as 3 squared. Hold on, I didn't mean to put that there. Actually, I could have just left that there. I don't know why I did that. So you can either rewrite 9 as 3 squared like that, or you can use a logarithm with a base 3. If you use a logarithm, these will cancel and you get 2x equals, and this is 2 because 3 squared is 9. If you don't use the logarithm, you would write it like this. You would rewrite 9 as 3 squared, and then you would take the exponents and just set them equal to each other. And so we are at the same point we're here, and then you get x equals 1. So either way, x is 1. Okay, then we have another one. Okay. So the other one.
I like to go to space.
I would have spaced it out a little differently.
The other one is log 5 minus log y equals 1. And then you're going to use logarithm properties. When you subtract logarithms with the same base, you can divide them. So this becomes log 5 over y equals 1. And when you add them, you multiply. So if this said plus, it would be log 5y. Since it's minus, it's 5 over y. Then you take the base, which is 10 if you don't see one. You raise it to this power, so that's 10 to the 1. And you set it equal to what's inside here. So 5 over y equals 10 to the 1 power, or 10.
Wait, can you refresh my brain on why you put the 5 over y?
It's a property of logarithms.
Yeah, but logarithms will make
It's when you add, but when you add, you multiply.
And then now you just solve, so you would just multiply by the y, and then divide. You get 1/2 is y.
The seniors are still here.
They go to their AP classes. Okay, so x is 1, y is 1/2. Number 2, you're using that like special area formula that you used on Math Excel to find the area of the triangle. Put the points in a determinant, x, y, x, y, x, y, and then you put the last column as a bunch of 1s, and then you take half of it. So you're going to set up a determinant. It's 1/2 times, put the x and the y in next to each other, so x, y, and then you just put the rest of them in the same kind of order, x and y, x and y. And then you're going to fill in the last column with 1s, and you're going to find the determinant of that matrix. So since it's a determinant, these are straight lines. They're not matrix brackets, they're straight. And it says without using a calculator, so you're going to show work. The first thing you do to find the determinant without a calculator is you rewrite the first 2 columns.
I think this is where I did something.
No, I did this.
I did this though. It just like looked weird. I don't know. All my answers like just didn't seem like they were like.
No, you know
what I
what I think I screwed up on? I guess because we equation.
Yeah, I got.
We're going to do 3 diagonals this way,
You're
So this first product is negative 12. This second product is negative 6. And this third product is negative 4. Then we're going to go the other way. This product here is 6. This product here is 16. And this product here is negative 3. Alright, so if I add up the first set of diagonals, I get negative 22. And if I add up these, I get 19.
It's
Yeah, 19.
22 minus
19.
319.
And so then when I combine these, because when you subtract, it's like adding a negative, that's going to be 41.
Wait, it's
Whoops.
plus 19?
Well, it wasn't. It was
Plus
minus.
negative 19.
So I added the negative 19.
Wait,
It's not plus,
It
it's
wasn't a
minus.
negative already.
Negative 20.5.
It was this.
It was a
It was
positive.
19, but we're subtracting.
Positive. It was positive. And you subtract. And so then you take half of 41, which is negative 20.5. But since we're finding area, we just say that the area is 20.5, not negative 20.5. And you could check your answer with your calculator.
Choose an answer.
Okay, so in number 3, they give you the coordinates of A, B, and C. And first, you're going to rotate the triangle. It may be a rotation, it may be a reflection. It's going to be one of those things. So know all the rotation matrices and the reflection matrices. Technically, there's 4 rotation matrices and 4 reflection matrices, but one of the rotation matrices is 360, and that's just the identity. So
Right.
your test is tomorrow.
I meant,
What?
Yeah,
that
your
was a
test
no.
is tomorrow.
oh,
No.
oh my god.
I'm so excited.
So don't get the layout of 3 and 2 confused. So with 2, we put x, y, x, y, x, y next to each other. But with these, we put the x's on top and the y's underneath them. And the reason we do it this way is because the rotation and reflection matrices are like a certain way that we have to put the x's on top and the y's on the bottom. So we always put the rotation or reflection matrix in front.
Oh crap, I didn't even remember. Oh my god.
Does anyone remember the 180 rotation matrix?
That
It's
would be
negative,
zero,
negative
negative
1,
one.
0, negative 1.
Very good, Kristen.
Okay, so it says we're going to rotate the triangle 180 degrees. So then after you rotate it, you're going to get a result. The result is going to be that all of the coordinates are switching signs. So this will be negative 4, negative 1, positive 2. This is going to be negative 1, negative 3, positive 6. If you're not sure, just use your calculator to multiply.
Yeah, that's what I'm going to do.
You
Yeah,
don't flip
that's what I'm
it.
gonna do for every single question. 'Cause
Then it also has some additional information here. It wants you to translate it up and to the left.
So you have to multiply by
You
2
add
and
and subtract.
You're going to add and subtract.
then,
So to go up 2,
Up to
That
plus
X.
2 for the y's.
so 2 for the y's is down here,
And then minus 5.
and then minus 5 for the x's. That's the left.
See, this I understand.
this one's fine.
So that's going to give me negative 9, negative 6, negative 3, and then this is 1, negative 1, and 8. And then the last thing you're going to do is just restate what the new coordinates are. So
we
A
have to, like, write it
prime,
out?
yeah, write it out. A prime is negative 9, 1, B prime is negative 6, negative 1, and C prime is negative 3, 8.
What does the prime thing mean again?
It's
Prime-
the opposite.
Prime
Oh,
means
very
that you have done some sort of transformation.
Are we gonna like get points off when we don't just like state the coordinates? Like,
You have to-
that's
Well, it's not A, B, and C anymore. It's something else. So that's how we say that it's something new.
I'm so gonna forget that.
No,
That
It's
is
just,
one
no,
of
it's
those things.
literally what B turns into, what A turns into, what C turns
No, I understand. I'm just like saying like that's something I would forget.
Well, forget it.
Optimus Prime, remember that.
It's important because if
What?
you say it's A, B, and C, then you're saying it's what it was when we started, and that's not true.
Yeah, I suppose.
So you're mislabeling it.
Emma,
Will
just
you
remember
give
Optimus
points off
Prime.
for the
I don't know what that
brackets?
is.
B. is multiply the elements in this matrix by 2. So you're going to do some scalar multiplication. So that's 14, negative 10, negative 6, negative 8, 16, and 18. If we want to get B by itself, we would need to get rid of this matrix somehow. So to get rid of it, we could subtract it. So we'll take this matrix and subtract it on both sides. It's going to go away on this side, and then over here we're going to be subtracting 10, 6, 2, 5, negative 4, 1, and 14, negative 10, negative 6, negative 8, 16, and 18. So I didn't change any of the numbers in the matrix, I just put them to the right of this matrix and I'm going to subtract. So 10 minus 14 is negative 4, 6 minus negative 10 is positive 16, 2 minus negative 6 is positive 8, 5 minus negative 8 is positive 13, negative 4 minus 16 is negative 20, and 1 minus 18 is 17. Negative 17.
Like, you keep like writing stuff and then putting stuff on the left, and I like don't put room for that.
So now what do you divide?
Now you have to get rid of this number. You don't divide matrices, you have to multiply by a scalar. So what scalar is going to get rid of a negative 1/2? Right, so you're going to multiply this by negative 2 and this by negative 2. So you're going to take all the elements in this matrix and multiply them by a negative 2.
Why is it negative 2?
Yeah, why?
Because negative 2 times negative 0
Oh, okay. I don't think I would know that though.
Yeah, I wouldn't have just known that.
Let's multiply all these by negative 2, and you're going to get positive 8, negative 32, what is that? Negative 16, negative 26, positive 40, and positive 34. And you can check some of this stuff on the calculator too. Like you could check your subtraction here on your calculator. You could check the scalar on your calculator if you want, but I would do that at the end and not maybe in the middle just in case you run out of time. One of the things we've been doing is solving like equations using matrices. Back in like, I don't know, chapter 3 when we solved systems, the very first kind of application for systems of equations was we graphed lines and then saw where they intersect. That's the same thing as solving the system of equations. So this question is just worded differently. It says where do the lines intersect? Same thing as solve the system of equations. Okay, this particular question wants you to use inverse matrices. We can't use inverse matrices when they're in this form. We would want everything to be in this kind of form. So standard-ish form. Doesn't have to be perfect, like you can keep the decimals, but the x's and the y's should be on the left. So for the first equation, you would subtract the 2x so that it's on the left side with y. And then the second equation we would add the 0.3x again so that it's on the left side with y. So we have this system that looks a little bit better.
Oh my god, I wrote it in bad.
Let's take a look at this.
I had some problems with my
Let's see
spacing
what it
today.
goes. Let's take a quick look at this.
I'll give you more space on the test. I'll make it 3 pages.
Oh.
So for this one, we would put all the coefficients in a coefficient matrix. So that would be negative 2. If you don't see a coefficient, it's 1. This is 0.3, and this is a 1. Then you put your variable matrix in, whatever variables they are, and then equals the constant matrix.
Oh, that's what it is? On the quiz I just had a matrix that always stays the same.
Yeah, that's what I
That's
said.
I said it doesn't change the value.
And then I said the other one was one that does change, but I mean
That's funny.
Perfect. I'm glad that we're all
Wow.
doing so good.
That's so funny that you said the same thing.
I didn't know what it was.
I said it
That's
stays
a
the
good
same
guess.
throughout. I said it stays the same throughout the problem.
Can you just get credit for just like us trying that hard?
We'll
It's
see.
trying to use proper grammar.
No, I really.
Alright, so
I don't
we have to multiply by the, it says solve using inverse matrices, we'd multiply both sides by the
I
inverse.
feel like when you see how
So
bad
that's
I
On
did.
the left side of the equation, you're going to multiply by the inverse and you're going to get the identity
So
matrix.
you're multiplied by -1.
Yeah, but I'm just gonna write that because
No, you're going to raise it, you're going to find the inverse.
Maybe that's what we did.
On the left side, I'm going to actually find the inverse. So the inverse is 1 over the determinant. So -2 minus 0.3. Then you flip these two, and then these two, you make them have opposite signs.
The thing is, I did all of this. I don't know what I did wrong, but the answer could not have possibly been correct. Like it really
You probably
I got
multiply wrong.
-169.
Alright, and
That's
then
pretty bad. I don't know what you're talking
on the left side, the identity matrix times xy is just xy, so nothing's going to really happen there. Here we get 1 over -2.3. And then, yeah, so if it's the quiz and you can't use your calculator, you would multiply, you'd get 5 plus 0, so that's 5. And then on the bottom we get -1.5 and 0, so that's -1.5.
Oh, that's what I did wrong.
And then you would just multiply both of those by
I did that too. I don't know what
that scalar, and probably have used your calculator at this point,
See,
actually.
I got the 1 over -2.3, and then I multiplied that by all of the 1 -1.
Oh, that was your problem.
So on your
I did.
calculator, what you would do
Okay.
when it loads,
I feel like I should charge mine soon, but I also don't.
Is that a
know.
15?
just leave it in here and then it'll be here
Wait, Coach
tomorrow.
I'm gonna screw some
That's a
like
15,
steal it.
right?
People take them.
It's a
I have my
1.5.
charger at home. I just don't feel like charging it. Don't do me like that.
So,
Oh.
on your calculator, you could just take the square matrix, like the coefficient one,
It's what's his face?
and then you can raise it to the -1 power and multiply it by 5 and 0. It's not the cutest decimal, unfortunately.
What is that?
Yeah, well, I kind of just threw some numbers on the page, to be honest. So let's just round to like 3 decimal places.
Wait, can you just explain to me really quickly where you got the 5 and -1.5?
They're about to play like on 100 on the quiz.
And
they're around
multiplied,
100,000 twice.
you multiply these two and then these two, and you add. So 5 and 0. And then you multiply these two and these two. So -1.5 and 0.
Does this kid have advisory with you or something?
Yeah, he does.
Just draw during advisory.
Yes. Alright, so these are rounded answers, but x is -2.174, y is 0.652 approximately. If there's fractions, fractions are better. We could have gotten the exact answer with fractions by, if we had multiplied this first equation by like 10, got rid of the decimal, we would have had more accurate answers, but whatevs.
My calculator. Like, I honestly don't have a problem with when I have my calculator. It's when I actually have to do the work. It's not
Well, that's why they're
ideal.
2 different grades. Alright, so we got, we have a vector here.
These ones are the ones you just like add and then, or
Yeah, you're gonna, like,
Where are the
subtract.
scalars at?
So to put this point in component form, we're gonna subtract terminal point minus initial point. Alright, so you're subtracting that way. We get -6 and 4. That's your component form. And you put the little pointy guys around it.
Oh, this is when we use the little pointy guys?
The little emojis.
I always write the little, I always write parentheses instead because I just like, it's just habit.
Vector v has a different terminal point, a different initial point, so you'll do that too. So terminal point minus initial point.
How do you
No.
know which one to sit? Like, how do you know which one goes on top and which one goes on bottom?
Terminal point minus initial point.
Is this our last test of
Oh.
the year?
Yes.
This is going to be 2. This is -6. So there you go. 2, -6.
Actually, it might not be.
And then you're going to find the magnitude of u minus v. So first, let's just find u minus v. To find u minus v, you're going to subtract the first part there. And the reason you're subtracting is because it says minus. If it said plus, you would add them. So -6 minus 2. So that's -8. And then you're going to subtract these, the vertical component, and that's going to give you...
Absolute values.
We're not there yet. So 4 minus -6, that's 10. These vertical lines mean the magnitude of u minus v, not absolute value.
Right. I forgot what we did that.
So to find the magnitude, you take the square root of -8 squared and 10 squared.
And this is gonna be with calculator. Oh, wait,
I would just simplify, yeah. So this is going to be 64, this is 100, so that's 164 in the square root, and then we would attempt to simplify that. So,
Well, can't you just simplify it already and just know that it's 8 and 10 and know that it's 18?
but that's the sum of 8 and 10, not the product of 8 and 10.
That makes a difference.
Yeah.
Yeah, sum and product are 2 different things.
You have to square them, add them, and then square root them in that order. You can't square root them and then add them.
I'm just- I don't know why
It matters what order you do it in.
Yeah, that's why there's PEMDAS.
What's something that goes into 164?
2.
Okay.
Wait,
Or
16 and 4 is 20.
4 also works.
Doesn't go into 3.
2.
It does go.
Thank you,
It goes
Tristan.
into 4 though.
What goes into 82?
Steelers.
9, 10,
2.
4.
Thank you, Tristan. Tristan is saying every
2
number.
and 41, and that's
Oh my god.
the end of that.
Really?
I thought-
So
I thought 7
2
times
root
7 was
41.
Wait.
7 times 7 is 49.
49, Emma.
I'm 41.
Having a rough day. Literally chemistry, get rid of it.
So you have,
Oh my god.
It's
just to
literally
give you a visual, you have like a pretty potent,
Rude. I'm on my way to leaving.
you have a less potent. And you want to mix them together to get,
Do you have to draw the pictures?
no, I said, just so you have a visual.
Explain.
Thanks.
Wait, why do they look like that?
Yeah, what kind of jars?
They're
Listen, I just was rushing.
It's not a beaker. It looks like you know. It looks like the food that you like the
It looks like a
stocking. A
pillowcase.
stocking in
You're a pillowcase,
for
right?
Christmas.
Alright.
I look like a pillowcase.
Focus.
I'm that pale.
I need a variable that can represent what I'm trying to figure out. So what am I trying to find?
Trying to find Z.
50%.
No.
50%. Hydrochloric acid. Oh, wait.
What about it?
20 ounces of.
How much?
Ounces. I need to know how many ounces of this and of this I should mix together to get 20
I don't
ounces
get
of
how you add
this.
17, 20, and get 50. I'll never
Because
understand.
because it becomes a compound. There's other elements that evaporate or become.
That was
like-
not correct. The first
The
one.
number of ounces of 70% hydrochloric acid. And then I'm going to say that Y is the number of ounces of the 20%.
But how come they're all hydrochloric acid solutions?
Bring it in. Okay, so first, let's think about
That
percentages.
doesn't make sense.
70%
That's what you were saying.
of X
There were different elements.
plus 20% of Y is going to yield 50% of both of them together.
I don't know. I'm just, hold on. I'm
How
just-
much of the 50% solution do we want to have?
It's 20.
20. So here we're going to put 20. It's 50% of the 20 ounces. We know that total is going to be 20. We just don't know here what those will be each. Maybe it's 10 and 10. Maybe it's 15 and 5. Maybe it's 5 and 15.
How did you notice set it up like that?
Without the percentages, we have some unknown amount of 70%. We have some unknown amount of 20%, and we know that when we add those together, we should get 20 ounces.
Yeah.
This just puts a value to that. So it's like the same kind of equation, it just puts the percentage.
Are you
On
multiplying
there.
20 there, or are you just saying
Yeah.
0.5 is?
No, you're gonna
Okay.
multiply them.
Okay.
Yeah.
I think that's what I was more confused about. I was like, what?
Yeah, so it's 50% of how many
And then that's the
ounces.
second one's the other equation, right?
Yeah, so let's, if we like you said, if we multiply by 20, this is going to be 0.7x plus 0.2y equals 10. So this is your system of equations.
That looks dummy in the eye.
And then you're going to solve your system of equations using inverse matrices.
It's so hot in here.
Actually, a little chilly right
So
now. Your arms so long.
make it a matrix equation.
I either have to sacrifice myself right now.
Put your coefficients here,
Maybe not.
variables here,
Sorry, what's wrong? Didn't do
and then constants here.
Get in trouble?
my job.
For what?
Because I look what I'm wearing.
Why you really dressed up today?
I know, I thought it was a choice. I read your text, and my mom was like, it's just down there. I'm like, what? Yeah, okay. You can test me all you want.
Like-
sure.
Especially, you're going to take the inverse of this matrix on your calculator and then multiply by your constants.
Whoa.
So,
Whoa.
Oh my god.
That
I
came
got
out
the
of
problem.
nowhere.
Can you
They're
please
like
move to the right a
teleported
little
there.
bit?
now.
Thank you.
So
that what you're writing
0.7,
now, right?
no wait, just kidding, it's not 0.7, it's 1, 1, 0.7, 0.2, to the negative 1 power, times 20
I
and
feel like
10.
getting to the equation is the hardest part.
Yeah. And so I get 12 and 8. So that means we want 12 ounces of the 70% and 8 ounces of the 20%.
What did you just write that?
I don't know up
At the
there.
top.
Oh. And that's the answer.
Yeah. So 12 ounces of 70%,
I put
And
8. Oh, wait, it looks like
8 ounces of 28%.
I really
Why don't you put in a
8 ounces
determinant
of the Persian
for a country?
Kramer's rule.
I'll tell you this.
Kramer's rule.
Okay, I'll be ready.
The admission fee at a small fair is $1.50 for children,
Okay. You're right.
and then it is $4 for adults. On a certain day, 2,200 people attend, and $5,050 is collected from that sale. How many people, combination of children and adults, attended? $1.50, one child.
Oh, one.
We are going to set up some equations. What are our
When you
variables?
just say
X
50-50,
Is gonna be the
Why'd
child,
you just screw this X?
and Y is the adult.
Okay, what? It's not the adult. X is not the name of the child. What is it representing?
X is
The
150.
amount of
The
children.
amount
amount
they
of
have to
children.
pay for the
X-Men,
admission
so
fee
X
for
equals
We
children.
know the amount
How
they have
many
to pay.
children?
The
Yeah.
amount of children.
The amount of children.
I think it's time for me to take these off.
What are they?
They've done their fair share.
They really, but like, are you really trusting without them? Like, they've been there forever.
Have they done a fair share of this
That have been on there for like 2 years.
Okay. One
Oh,
equation
God.
will deal with the quantity of people that came to the fair that day. So X plus Y equals 2,200. And then the other equation will deal with the revenue. So we had, or I guess, yeah, $1.50 for the children, $4 for the adults, and a total of $5,050.
I have a question.
Yeah.
So for all of these, are we supposed to have 2 equations or 3? 'Cause
If you have 2 variables, you need 2 equations. If you have 3 variables, you need 3 equations.
Makes sense.
5D.
So we're going to make a matrix equation out of this. That's 1, 1.5, 1, 4 times xy equals 2,200 and 5,050. This one says to use Kramer's rule, not inverse matrices.
I like that one better, I'll still get it wrong.
Kramer's rule is determinants. So you're going to set up some determinants for x and then some determinants for y.
Yeah.
So for x, you're going to replace the first column with the constants, because x is our first variable.
You write so fast.
And the second column will just be your coefficients of y. Then you're going to divide that by the coefficient matrix determinant.
See, when I have a calculator, this is so easy. But like, other than that, it's just not.
It's really not that hard without a calculator.
You
I
just
beg to differ.
you just take the
You just
220
do
and the 4.
these multiplied, which is 8,800 minus 5050. But anywho, we can use our calculator.
Yay.
Do we just put a determinant?
So you're going to type in the letters DET parentheses. Maybe you want to make this a fraction. Not that a fraction. Hold on. Maybe you want to make it a fraction first so you can do the top and the bottom. Then you're going to do DET parentheses. Put in your square matrix.
Ow, ow, ow.
And then do the same on the bottom. DET parentheses.
You want like a dog?
Like a dog or like a dog?
Okay, so I got 1,500.
Like a dog or like a dog? You said like a dog.
So when it's a determinant, things are straight.
Do you want an English riddle?
Then if you want, you can find y just with like
They're so cute.
substitution. How many people went to the fair that day?
I did.
2,000
2,200. So if 1,500 of them are accounted for by
Wait,
children,
Do you know why my
Where'd you get
letters?
there were
Right,
1,500?
that's
Oh,
Do you know why my letters are capitalized?
700.
yes.
You have caps lock on.
Why?
You have caps lock on.
I don't understand how it's a
So determinants are related to the Kramer's rule?
So there were 1,500 children and then 700 adults.
Punch guy, but
What is papaya taste
This is fruit punch. It's bananas, oranges, and papayas.
Think of it.
Shh. There are 7 pieces of fruit. 7 pieces of fruit in the mix. So maybe there's 3 bananas and 1 orange and 3 papayas. I don't know.
Okay.
There are twice as many oranges as bananas. So there's more. There are more oranges than
It
bananas.
should have been 5.
You also know that the pieces of fruit cost $5.25. The bananas cost 50 cents each, the oranges cost 75 cents each, and the papayas cost $1.25 because papayas are expensive. They're also gross.
What?
How many bananas, oranges, and papayas should go in the punch? So, what are the variables?
X, Y, Z.
Really?
Why
You're
is it
sticking
straight?
with that?
I mean, yeah, because it confuses me. if there
Just
are
do
no
B.O.P.
just do T B O.
Tristan, but like that's so confusing.
B.O.P.
Just do X, Y, Z.
Okay, what is X?
Bananas.
X is gonna be the. Why would you do it in the? Yeah.
Yeah,
you're
number
right.
of
And then
bananas.
oranges can be Y. And then
Papayas are Y.
Y is our oranges.
Why are you taking one out?
And then Z is our
Apples.
papayas. Okay, guys, this doesn't work if we're all talking. This only works if we're all listening. Alright, so X is going to be our number of bananas, Y is going to be our number of oranges, and then Z is going to be our number of papayas. So for our first equation, we can write the cost of all of these. So if bananas are 50 cents, that's 0.5x. If the oranges are 75 cents, that's going to be 0.75y.
Very cool, very cool.
And then the papayas are $1.25, so plus 1.25z. And this is a total of $5.25.
What? Oranges aren't tropical.
Oranges are tropical.
Oranges are tropical, that's why they're in the tropical punch.
What?
No, what makes it tropical are the papayas.
No.
Yeah.
Okay, so we dealt with the cost. What else do we know? How many pieces of fruit are in the mix?
Why did I say
Okay.
X plus Y plus
So x plus y plus z
Then
is
it's
7.
Wait,
Okay, so we dealt with that. What's the last thing?
it's actually Thanos.
There's another one.
It's Thanos.
Yeah, that's hiding.
And oranges should go in the punch.
No, there's more.
Tristan, that is the. Okay. I'm just.
Oh, there's 7 pieces of fruit.
We did that
already
one.
just did that.
Oh, there's twice as many oranges.
-2x plus y. Negative
Twice
2.
as many oranges as bananas means that bananas is 2. No, wait, twice as many oranges as bananas. Just kidding.
So, but you double the bananas.
Yes.
So it's 2y. X equals 2y.
No, wait, oranges.
Wait, there's twice as many oranges as bananas.
Yeah, so it's y equals 2x.
That's what. Oh my god! I was supposed to be 5 through in turn. I wrote 10. I wrote 10, 20, and.
So you want to double the smaller amount to get the bigger amount. So if y is oranges, we want more oranges. I hate papayas.
You have issues, my dude.
He said it so like.
You have
oh,
serious
yeah.
issues. That's
Okay.
what it tastes like. And
Hey,
it's
well,
so
you
Chinese
guys
people
are
like
really
everything.
No, what is like?
Actually,
Like dog meat tastes good.
This class is like fun.
Our
It
class
tastes
has
like
so much-
beef.
I don't know about that.
It tastes
Like
so
okay, you know how
gross.
people say frog meat tastes like chicken?
It does taste like chicken. No,
No, it doesn't.
alligator tastes like chicken. That's
No.
what it tastes like.
Okay,
No, it
alligator
does
does
not.
taste like
The
chicken.
consistency
But
of
dog
alligator
tastes
is
like
very
beef.
different than chicken.
Anyone who
It
says
just
that.
tastes like chicken.
Pork besides chicken.
Okay.
I've only ever had it
Oh,
fried,
that's
so
fine.
I
Frog,
don't know what
frog
it tastes
doesn't
like.
taste like chicken, but dog do taste like beef.
I feel like Dalton would
I mean, it's like, I guess it would be a red meat, so that makes sense. All right, are we ready for the next one?
Yeah. Let's do this.
Not that side of the room.
Also,
Hey,
Why
are we
do
ready
those-
for number
Do
10?
you have a gymnast?
why did
Okay,
those
no,
leaves?
stop. Good, I'll explain that later so that you're educated.
Pretty sure I've seen
All right, so we're going to use Kramer's rule on this.
Recording this whole class.
Just that last but I forgot to pause it. Tommy has to buy some pens, pencils, and notebooks for the upcoming semester. He has $102 to spend on $5 pens, $3 pencils, and $9 notebooks because he buys expensive pens. He would like to spend the same amount of money on pens as on pencils. He also wants the combined number of pens and pencils to equal that of the notebooks.
God, so x plus y. Wait, no, 5x plus 3y plus 9y equals 102.
You had too many Y's in there.
I mean, why did all the men with y? 5x plus 3y plus 9z.
What's X going to be?
And
Pens, y is pencils.
No, I think X should
and
be
9 is-
notebooks. To
Shut
be
up!
honest.
No, you have to stay with the order.
No.
9 is, Z is notebooks. There you go.
X.
Okay.
notebooks.
All right, so then you were saying $5 pens plus $3 pencils equals $9, or plus $9 notebooks equals $102.
So,
How come we don't get
No.
anything like
Shh, can we not? Stop interrupting every question. Let's just get through it.
okay, sorry.
Okay,
Holy crap.
he would like to spend the same amount on pens as pencils.
why is there
5x equals 3y.
Okay,
Is that right?
I did.
yeah,
Oh, okay.
Oh, really?
right? That's pens and pencils.
Yeah, that is pencils.
I suppose that'll work.
Oh, yes.
We'll rewrite that later.
I'm gonna do it now just because I want to.
Okay.
Let me get my little highlighter out.
Shut up.
Let me get this-
Oh god. And that's gonna equal 0, right? Yes. Oh my god, I have Spanish for hours.
Yeah, when you rewrite it.
so
You get to play
x
with
plus
Blue,
y equals z, right?
And you just haven't had a chance to talk to me.
So, yeah, the last one, the combined number of pens and pencils,
So it'd be 5x plus 3y.
just number,
X
not
plus
price.
y is
Y.
there,
Yeah, x plus y equals z. It doesn't say the combined price, it just says the combined number.
So just be negative z.
Tyler, stop to me.
Yeah, so then I'm going to rewrite all these. So all of these rewritten, we would keep the first one, there's nothing wrong with
I
it.
don't have, like, equations. Wait, did you guys erase? Never mind.
Then for the second one, we're going to subtract 3y.
Oh, you're rewriting them? I was confused.
Yeah, I'm rewriting them.
I already did that. Okay.
And then I'm going to subtract z.
My toes are freezing.
That's your problem. Put on some socks.
Okay,
Socks and sandals.
Yeah.
let's make this into a matrix equation.
5, 3, 9, 5 minus
Minus 3, not negative, just minus 3.
3. Yeah, minus 3. And then 1, 1.
Wait, are we doing determinants right now or no? Because you kind of.
Yeah,
Okay, there you
We
go.
will. Well, I'm not doing them yet, I'm just writing the equation.
Josh won.
Alright, so that's the matrix equation.
You keep moving my table.
Oh, sorry.
And then-
It's okay.
So our second equation has just an x and a y in it, so it would be best if you solved for x or y first.
Right?
That would be like the fastest way to do it.
Because it's just easier.
Yeah, so x equals, we're going to replace the first column with 102, 0, and 0. Then we have 3, negative 3, and 1. And then 9, 0, negative 1. Divided by 5, 5, 1, 3, negative 3, and 1, and then 9, 0, negative 1. Okay, so find x first, and then y and z will be easy to find. So remember to use determinants, type in det, and then don't forget the parentheses. If you forget the parentheses, it doesn't work.
That's unfortunate.
Wait, if it doesn't say Kramer's rule, we could also use inverse matrices for this.
It'll tell you which one to do.
It'll tell you to either do Kramer's rule or the inverse.
Like either works if it doesn't save, right?
Right.
I mean, I mean, it's the same thing, just like different.
So if you want to check your answer using inverse matrices, you could. Like if you're more comfortable with that.
Because it seems more easy to just put into calculator and just
So yeah, it is.
No, because mine are.
So then for x, I got 3.
These are really rich.
plug it in.
So that's 3 pens.
Wait, what? 3 pens is like
I think
Okay, so if I get 3 here,
5 pencils.
then that means I have 5 pencils. And then I have how many notebooks?
X equals
Both of these together.
8.
Y
8.
equals 5,
Wait.
Z equals
So the last two we just find by substitution.
Feels like